So let's look at homogeneous differential equations. So we have already looked at how we can determine solutions for general solutions of some differential equations by means such as separation of variables, as well as perhaps using, like, you determine the integral by integral factor method as well. So what it is now is that we are focusing our attention on homogeneous differential equation. So what are homogeneous differential equations? They are just simply equations that are in they are first order differential equations that are in the form where you have m x comma y dx here, okay, dx plus n x comma y dy is equals to 0. So what really differentiates homogeneous differential equations from the rest is the fact that we are equating it to 0. Okay, and we are going to understand this a little further when we talk about non-homogeneous differential equation, where you are equating the differential equation that you have to maybe an exponential function, a trig function, as well as maybe an algebraic function. We are going to understand that better when talk about non-homogeneous functions, non-homogeneous differential equations rather. Okay, so when you have a differential equation that is in this form and you equate it to 0, what you simply have is a what? It's a homogeneous differential equation. So for it to be homogeneous, okay, for that differential equation that you have for to be homogeneous, this part that you have and this part needs to be what? They need to be functions of the same degree. It is such that if you have a function f of xy, okay, so what it is that if you have a function of f of xy, I wouldn't want to write it in this way. For me to determine if it's homogeneous or not, I have to multiply this x by t, then I say comma y by t there is equals to, I'll say t alpha, then my f x comma what, x comma y. So if this and that are equals to each other, then the function that you have is what, is homogeneous. You can also be given a function, then you just try to determine the the degrees of the variables that you have, such as maybe if you have f of xy is equals to what, is equals to x plus what, x plus y, like that. So you determine, you observe to say here you have a degree of 1 and you have a degree of 1. You can simply conclude from there that that is a what, that is a homogeneous function. If not, you can come and say, okay, where this x I put f of xt comma yt there is equals to, instead of saying x, I'll say what, I'll say x xt here plus what, plus yt, of which if you factor out the t, this is going to be t x plus what, x plus y, like that. So you observe to say this is t, more like t alpha, but in this case your alpha is what, your alpha is 1. So it's the same thing that you have here, which is that being equals to what, being equals to that, which is the same as what, same as what you have here. So hence is what, is homogeneous. So you can use this method, or can you just observe the degrees that you have, they are the same, meaning is what, is homogeneous. All right. So let's get to look at some examples. But before I do that, so when you're given a function, before you I mean after you determine that you determine and confirm that it's homogeneous, you're supposed to use some form of substitution for it to make it for you to put it in such a manner that you're able to use a separation of variables, or maybe a certain method to really determine the general solution. But in this case, we focus our attention on separation of variables, where you're going to perform a substitution where you're going to say y will be equals to vx. Okay, any at any point where you have y in your function, um, or let me say your equation, you're going to say you're going to substitute with vx where you have y. Then instead of you having dy dx, you're going to say your dy dx is going to be equals to v plus what, v plus x dv dx. Where does this come from? This comes from the fact that if you have this one here, okay, if you have your y if you have your y to be equals to vx, if you have your y to be equals to vx there, so what it is that you're going to differentiate this with respect to what, with respect to x, meaning you're going to say your dy dx will be equals to um, so when you differentiate this part, what you're going to get is that if you differentiate with respect to x, then you're going to get what? You're going to get a v. Okay, then plus this is a product. You're going to, it's more like you're using product rule. So in this case, it's like you maintain v, you differentiate x, you get 1 by v, that's a v. Then you're going to get plus, you maintain x, differentiate v, you're going to get dv d what? Dv dx, like that. That's where this part comes from. Okay, so these two substitutions are very important. It's very critical that we keep them dear to ourselves, because we're going to be using them a lot as we do a lot of examples. Okay, so let's try to look at some few examples. We try to make sense out of what out of this theory that we have understood here. Okay, so the first example that we are going to look at is that let's say you have dy dx to be equals to x plus what? X plus y over x. So what it is that you can confirm that this is homogeneous by saying, okay, what if I say f of x t comma what, comma y t? This by using this method, and you confirm to say it's your t alpha, then here you have your what, your f of x comma y. If you try to use this method, you're going to confirm that this is what, that this is homogeneous. For the sake of time, I'm not going to go through that process. I already confirmed it's homogeneous. You can try it out to confirm on your own that it's homogeneous. The only thing that I'm going to do right now is to determine the general solution. So I know that my dy dx is just v plus x dv dx is equals to my x plus, where there's y I put vx, divide by x. So I can factor out the x, that will be your x 1 plus v, divide by what? Divide by x there. This goes and that goes. I remain with what? 1 plus 1 plus v, like that. So I simply have like this v and that v can go. So you observe to say what you have is simply x dv dx is equals to what? Is equals to 1. So now we can do the separation of variables here. I can multiply both sides of that by 1 over what? 1 over x, as well as multiplying it by what? Both sides by dx. So what I'm going to remain with is just the integral of 1 dv, or let me just say dv, then multiply by is equals to the integral of 1 over x dx, like that. So where we have reached now is just a matter of integration here. So the integral of 1 in respect to v, with respect to v is equals to v. Then the integral of 1 over x is simply ln of what? Ln of x plus a constant. So that constant, I'm not just going to write it as a c. I'm also going to write it as what? Ln of what? Ln of c. So either use c or ln of c is simply one and the same thing, because overall this is just a constant. If you differentiate, this will give you a 0 still. Okay, so meaning here I can say alright, so my v is going to be equals to ln of, we know the properties of natural logs, whereby if they're adding each other and the bases are the same, what do? You we are going to multiply them. Okay, we are going to multiply them. If they are subtracting each other, you're going to divide, or let me say you're going to say the positive one divided by the negative one. If they were like you had one negative, the other one positive, since both are positives, it's just going to be what? Natural log of xc, like that. So remember to say we from we the substitution that we performed is that we said our y was equals to what? Vx, meaning our v is equals to y over x. So you can come back and say here y over what? Y over x is equals to ln of xc, like that. So you can multiply both sides by what? By y is equals to, multiply both sides by x. That will give you x ln of xc, like that. So you observe to say this is the general solution that we have. If I didn't put ln of c there, I just had to put a c. That was going to be y is equals to x open bracket ln of x plus what? Plus c, like that. So that is the general solution. This is still a constant, and even this is still a constant as well. Okay, now let's try to look at another example. Okay, it's very important that we do a lot of examples That's the only way we're going to become familiar with these stuffs. So let's say we are given 2xy dy to be equals to um, x squared plus y squared uh, y squared dx. Okay, how can we go about that one? So we observe to say this one, we can write it as a dy dx to be equals to what? X squared plus what? Plus y squared divided by what? 2xy. So once again, maybe let me try to show that this one is homogeneous, but I already confirmed it is. I could have just gone straight and found the general solution and leave the work for finding if it's homogeneous or not to you, of which I already know it is. So where there's x, I'm going to put xt, meaning that's going to be t squared x squared plus t squared y squared divided by, I have 2 x xt here, okay, xt there. Then where there is y, we are going to put what? We're supposed to put yt. So this is more like yt, of which this just makes this t to be what? Squared. You can factor out the t squared like that. That's x squared plus what? Y squared divide by t squared. Then you have 2xy. So that in that goes, you remain with what? You remain with what you have right here. Hence, you confirm to say that is what? That is homogeneous. So I can perform the substitution right now. So where there's dy dx, I can put v plus x dv dx is equals to. So where there's x, I say x squared plus, where there's y squared, that would be v squared x squared, because we are going to we said we are going to perform a substitution where there's y, we put vx. So that's why this becomes v squared x squared. Then this is going to be 2x squared v. Why is it like this? At this point you put vx, x by x, that becomes x squared. So you can factor out the x, that would be x squared 1 plus v squared divide by what? Divide by you have your 2, let me not write 2 there. Let me say you have your 2v, okay, let me say x squared multiplied by 2v, of which I already know that and that is going to cancel out. So meaning I can take the v on the other side. Okay, on the other side, that gives me x dv dx to be equals to what? To be equals to 1 plus v squared divided by 2v minus v, which is that v that you have right there. You have just shifted it to go on the other side. So now you have your x dv dx to be equals to what? 1 plus v squared minus 2v multiplied by v, that's give you 2v squared divided by 2v. This just turns out to be x dv dx to be equals to 1 minus v squared divided by 2v. Okay, so now I can do this. I can multiply both sides by 1 over x. Okay, multiply both sides by 1 over x, also multiply both sides by dx, multiply both sides by what? By 2v over 1 minus v squared, which is just a reciprocal of that one there. So what you end up with is just the integral of 2v over 1 minus v squared dv is equals to 1 over x dx. All right, so at this point you can use u substitution, where you're going to say your u, let your u be equals to what? Be equals to 1 minus v squared, meaning your du dv will be equals to what? Will be equals to minus 2v, of which your dv will be equals to minus du over 2v. Okay, so this negative, I'm going to bring it outside here. I'll have 2v divided by u du over 2v, of which that and that goes, you remain with 1 here. Of course, you integrate with respect to u. So this is going to give you ln of x. Once again, I can still say ln of what? Ln of c. There is no harm, that is just a constant. So now the integral of the other part, you're going to get minus ln of ln of u like that is equals to ln of, we know the rule here, we are going to say this is going to be xc like that. Okay, so we observe to say because of properties of logs that can come here, we'll have ln of uh, u here. Okay, then we have -1 is equals to ln of xc like that. Okay, so now what do we observe is that the natural log goes. Okay, the natural log goes here, it has to go. Okay, the reason why it has to go is that it's very simple. When you look at the properties of natural logs, let me simplify this. If you say ln of a is equals to ln of, let me put that as b. This is just simply a is equals to what? A is equals to b. How is that a is equals to b? So this is simply log base e of a is equals to uh, log base e of what? Log base e of b. So in this case, what we are saying is that a is equals to this base, which is your e, raised to the power what? Log base e of what? Of b. Because you have e here and you have e here, a will be equals to what? A will be equals to b. That's why this part is equals to that. We should not think we were like dividing both sides by ln, then you cancel. No, that is coming from the properties of natural logs. Okay, so since here we have said our a is equals to our b, and our a is simply 1 over u. Why am I saying 1 over u? Because of the negative that I have there, I make it positive. So I'll have what? What's my b is xc. So remember, we said our u is equals to okay, our u is equals to 1 plus v. Okay, so that is like our u is 1, sorry, not plus but minus v, and we know to say our v is simply y squared over x squared is equals to what? Xc. So we can make y the sub of the formula here. That is going to give us x squared minus y squared divided by x squared is equals to what? Xc, like that. Okay, so now this can also be written as x squared over what? Over x squared minus what? Minus y squared, because that was just simply 1 divided by x squared minus y squared divided by x squared. So if you change this to multiplication, you're going to say it's 1 multiplied by a squared over x squared minus y squared, which is simply what I've written right there. So this is simply equals to x c that I have there, x multiplied by the constant. Okay, so I can say divided by 1 here. This is going to be x squared will be equals to xc, then I have x squared minus what? Minus y squared, like that. Okay, can I have something that's a bit cool if I had to expand? Let me try. I can leave this as a general solution, but let me give it a try. X squared will be equals to x to the power 3 of c minus x c y squared. Have I done the right thing? Okay, think so. So meaning our x c y squared is equals to what? X to the power 3c minus x squared, like that. Okay, that's what we have. Then what is just remaining is just to say, okay, I'll divide both sides by xc and xc, like that. So that goes. So I have y squared is equals to, I can even decide to simplify this a little better, I mean a little further. So that's going to be like your x open bracket, your x squared c minus x, okay, divide by xc. That and that goes. So that would be like your y will be equals to the square root of x squared c minus x divided by what? Divided by c, which happens to be that the solution. All right. So let's try to look at another example on homogeneous differential equations. So let's say we have dy dx to be equals to x plus what, x plus y squared, like that. Okay, so what it is that if you expand this, you observe to say you will not be able to separate the variables, meaning I'll not be able to, you can confirm that it's homogeneous, of which we know it is, but will not be able to confirm that, I mean, we will not be able to use separation of variables, because by expanding this, this is going to give you something like x squared plus 2xy plus what, plus y squared. How do you deal with that one there? Okay, and this is like your x and y term being put together. And remember to say, when using separation of variables, your x needs to be alone and your y needs to be on its own as well. Okay, so how then do I do this one? So I can do some manipulation here, where I say, okay, I'll let my n be equals to x plus what, x plus y, meaning my dx will be equals to what, will be equals to, I'll get a 1 here plus, it's more like that's implicit, that's going to be dy dx. Okay, that's what we have right there. Okay, how does this then continue? So you observe to say here, where you have your dy dx, you can write your dn here. Dn dx is equals to 1 plus your dy dx is simply equals to that, but again, I'll not write it in terms of x plus y. So here you can allow yourself to do some manipulation, but the key thing that you have to remember is that don't change the meaning. So the way it is, like, I have dn here and I have n plus 1, I mean 1 plus n squared, which is simply easy for me to use as separation of variables, whereby I'm going to multiply both sides by 1 over 1 plus n squared, and also multiply both sides by what, by dx. This is just going to give me the integral of 1 over 1 plus n squared dn is equals to the integral of dx, meaning like 1 dx, which is just going to give you, that's pretty straightforward. So we have dx here. So this part you can use trig uh, we can use trig substitution here. So what I'm going to say is that I'll let my n be equals to what, because n plus 1 plus n squared, that will be, I'll say my n to be equals to what, to be equals to tan what, tan theta, meaning my dn will be equals to sec squared theta d theta. Okay, sec squared theta d theta. So I'll say, okay, I have 1 over 1 plus, where there's n squared, I'm going to put tan squared theta multiplied by dn is equals to what, sec squared theta d theta is equals to, this side we still have the what, the dx there. I've just done the integration. So you observe to say this is equals to what, is equals to that. So we are simply looking for what, 1 d theta is equals to 1 dx, or just d theta and dx. So here what you're going to get is that this is going to be equals to that's going to be equals to a theta. Okay, that's going to be equals to a theta, and that is going to be equals to what, to x plus what, x plus c. So now the question is that, what is your theta? Your theta is simply equals to tan inverse of is simply tan inverse of n. So I'll come here and say, instead of me using theta, I'll say it's tan inverse of n. I'm supposed to put n here, but what is my n? My n is x plus 1. So I'll put x plus what, x plus 1 is equals to x plus what, x plus c. Okay, which this happens to be what, the general solution, and I'll leave it like that. So once again, we can do all sorts of substitution that we like. The only thing that we have to remember is that we are not allowed, or we are not supposed to change the meaning. of what we are talking about. Okay, now let's say we have dy dx to be equals to x plus 2y divide by 3y minus 2x. This is already in the form of which we desire. If you try to determine if it's homogeneous, you put there, you're going to have xt plus 2ty, okay, plus 2ty there, divide by 3ty minus 2xt. This is still going to give you, when you factor out the t, you're going to get x plus 2y divided by what? Divided by 3y plus what? Wait a minute, that's not plus, but that's minus 2x. And that simply confirms to me that is what? It's homogeneous. And my alpha in terms of t is what? Is 1. Okay, so we can do the substitution now. My dy dx is simply v plus what? V plus x dv dx is equals to. So in this case, on the other side, I'm going to have x plus what? 2vx divided by what? 3vx minus 2x. You factor out the x, you have your x here, 1 plus what? 2v divided by what? You're going to have your x here, 3v minus what? 3v minus 2. That and that goes, you remain with that. And so what I can do at this point is that I can bring the v on the other side, so that will be like your dv dx is equals to 1 plus 2v divided by 3v minus 2. So now I have minus v here, okay, minus v divided by 1. So now this just gives me something like 1 plus 2v. That will give me minus 3v squared plus 2v divided by what? 3v minus what? Minus 2. That's what you're going to get if you do the if you make that as a single fraction. Okay, so we are still saying our x dv dx is simply equals to, we are saying it is 1 plus what? 4v minus 3v squared divided by what? 3v minus what? 3v minus 2 there. Okay, so now we can do the separation of variables where I've reached at this stage. So I can multiply both sides by 1 over x, also multiply by dx, also multiply by the reciprocal of that one, which is already in terms of v. So that's just 3v minus 2 over 1 plus v 4v minus 3v squared. So observe that this goes and that goes, and we do the same. So you're just going to get the integral of 3v minus 2 divided by 1 plus 4v minus 3v squared dv is equals to. So here we are going to have what? The integral of 1 over x dx. Okay, so for this part I'm going to use u substitution. Okay, I'm going to use u substitution. How is it then going to work? So I'm going to say, okay, I'll let my u be equals to 1 plus 4v minus 3v squared. So meaning my du will be equals to v, not v but 4. Oh my god, so that's going to be 4 minus 6v. Okay, minus 6v there. Minus 6v, how is that going to be? Minus 6v dv. So what you observe is that your dv is simply equals to du over, I can, the common factor for 4 and 6 is what? Is a 2. So I'll write this as 2 open bracket 2 minus what? Minus 3v. Okay, so you observe to say we're able to cancel out this, but what I should do is that I should make this as a negative. Okay, there's no harm in doing this. Then I do what? I put a negative here, so that when I multiply it becomes a positive. Then I put a positive there, of which you're going to say your dv is equals to du over minus 2 then I'll have 3v minus what, minus 2, like that. So now that's going to be equals to you have your 3v of minus 2 divided by your u by, I'll put the negative outside here, okay, which is this negative. In fact, I have to say negative 1 over 2. Negative 1 over 2. Why the negative 1 over 2? Because of that 2 that I have right there. Okay, so divide by u, multiply by what, du over 3v minus what, minus 2, which is that part. So this part and that part goes. Okay, so remember to say this is equals to the integral of 1 over x dx. So now for this part you can say this is 1 over 2 ln of what, ln of u. Okay, ln of u is equals to ln of xc. I think by now you know where x is coming from. I was going to say ln of x plus ln of c, because both are positive, we just add them together. So in this case we know how we deal with logs. I can bring the power here. That's going to be ln of in fact we know we have ln and we have ln there. We can get rid of those. We know how this is going to appear. Okay, that's going to appear as u to the power negative 1 over 2 is equals to what, xc. But remember, we know how to deal with that part. We can say it's 1 over it's more like the square root of u, but what's my u? My u is 1 plus 4v, but where is v again, I'll put what, y over x minus 3y squared over x squared is equals to what, is equals to xc, like that. Okay, is equals to xc. So the best thing that I can do at this point is that I can write this as, instead of saying 1 over that, I'm just going to say it is a square root of, or let me write it this way. I'll say 1 plus 4y over x minus 3y squared over x squared. Here, instead of saying xc, I'll say 1 over xc. Okay, by the way, this is raised to the power 1 over 2. Then for me to get rid of that, I'll just need to raise it to the power 2. I do the same on this side. So now this is going to be 1 plus 4y over x minus 3y squared over x squared will be equals to 1 over x squared times, multiplied by c squared there. That's what you're going to have. I'll leave it at this stage. You can go ahead and put it in terms of y. That's if you like. Yeah, and that's simply how we go about that one. So let's try to look at the last example in this tutorial. Okay, so let's say we have dy dx is equals to this is not too different from what we are just from doing. That's 2x squared plus y squared divided by 2xy plus 3y squared. So you can confirm on your own to say this is homogeneous. I'll just come and say v plus x dv dx is equals to what, minus 2. That's outside, by the way. Let me do this. Okay, it's like that. That's minus 2x squared plus v squared y squared, no, but x squared rather, sorry. So divide by, that's going to be 2x squared v plus 3v squared x squared. And you observe to say the x is able to go. You have minus 2 plus v squared divided by what? Divide by 2v 2v plus 3v squared. So you observe to say we can bring in the what? You can bring in the negative, the negative v, which is positive, but take it on the other side to be negative v, like that. So you have your x dv dx to be equals to minus 2 plus v squared. I'll have minus 2v squared minus 3v to the power 3, like that. Okay, then that is going to be divided by what? Divided by 2v plus 3v squared. Okay, so this is getting closer to closer to the way we want it. Okay, so now we can write this as x dv dx to be equals to negative. We have your 2 here, that's going to be negative v squared minus 3v to the power 3 divided by what? 2v plus what? 3v squared. So you observe to say you can distribute the negative on the numerator there. So this is going to be x dv dx is equals to, that will be minus 2 plus v squared plus what? 3v to the power 3 there, divided by 2v plus 3v squared. So now we can multiply both sides by what? By x multiplied by what? No, not x, sorry, but by dx, also multiplied by 1 over x multiplied by the reciprocal of that one. What you're going to end up with is the 2v plus 3v squared divided by what? Minus 2 plus v squared plus 3v squared, like that. So this just turns out to be the integral of 2v plus 3v squared divided by minus 2 plus v squared plus 3v the power 3 there, dv is equals to, so we only have 1 over x dx at this point on the other side. Okay, so now how does this end up? So we are going to find out that we can use substitution for the left hand side. We can let your u be equals to minus 2 plus v squared plus 3v to the power 3. So your du is going to be equals to, you have 0 here, that will be your 2v. Okay, 2v plus what? 2v plus 9v 9v squared, like that. Okay, have I done the right thing there? Okay, so I guess let me do this. So at this part, at this there's a part at which I was supposed to there's a part at which I had minus 2 plus v squared divided by what? Divided by 2v plus 3v squared. Then we had to bring in by the way, the negative was supposed to be alone. So in this case, if I distribute the negative, it becomes minus 2 minus v squared divided by what? Divided by 2xy plus 3y squared. Then I say minus v, which is the v that was on the other side. Remember to say we had v plus x dv dx. Okay, just want to rectify that. So meaning what you end up having is that, and the bottom part here, okay, the bottom part, instead of writing in terms of x and y, you're going to end up with your v plus what? Your 3v squared minus v. Okay, so this just turns out to be 2 minus v squared. Okay, minus 2 minus v squared. Then you're going to have minus 2v squared minus 3v to the power 3. Okay, divide by what? Divide by 2v plus 3v squared. So this just turns out to be minus 2 minus 3v squared minus 3v to the power 3 divided by what? Divided by 2v plus 3v to the power 2. Okay, looks like this has been rectified. Our specimen is going to be stuck there. That's going to be the integral of, we need to say that's a reciprocal, that will be 2 plus 2v plus 3v squared divided by what? Divided by remember to say I can factor out the negative. Okay, I can factor out the negative and put it here, but I don't want to stress myself by putting it here. When I can donate it to what, to x, which is this side. So instead of me saying integral of 1 over x dx, I'll say what, negative, because when you factor out the negative, this is going to be minus 2 plus 3v squared plus 3v to the power 3, like that. Okay, so I'll take it on the other side. So that's 2 plus 3v squared plus 3v to the power 3, like that. So once again, we can now utilize u substitution for the left hand side. So that's going to be, say, u will be equals to 2 plus 3v squared plus 3v to the power 3. So your du will be equals to 6v plus 9v squared dv. So meaning your dv is simply equals to du over, instead of saying 6v plus 9v squared, the common factor is a 3, so I'll say 2v plus 3v squared. So I'll come here and say I have my 2v plus 3v squared divided by what, divided by u, where there is dv. Okay, where there is dv, now we put what, du over 3, then I have 2v plus what, 3v squared is equals to minus ln of what, ln of c, ln of x, ln of x plus what, ln of c. So you observe to say this end that goes, you just have 1 over 3 multiplied by ln of u, 1 over 3 by ln of u, which is your integral there. But I'm not going to say u, I'll put what my u is. My u is 2 plus 3v squared plus 3v to the power 3 is equals to, here you know how we do with natural logs, that would be your ln of c over what, c over x, like that. Okay, we have simplified that part, and we observe to say the logs the logs are going to go for that part. Okay, the logs are going to go for that part. So now this is going to be, we know that we can bring this on, like raise this to the power 1 over 3. That's how we do logs, and I can get rid of it. So that's going to be 2 plus 3v squared plus 3v to the power 3 to the power 1 over 2 is equals to c over what, c over x, sorry, to the power of 1 over 3. So I can raise that to the power 3. I do the same on my right hand side. That's just going to be 2 plus 3. So where there is v, I'll put y squared divided by x squared, because we know what v is. Same applies to this one. Y to the power 3 divided by what, divided by x to the power 3 is equals to, that would be c to the power 3 divided by x to the power 3. Okay, so this is simply more like a solution. You can put it in terms of y if you like, but otherwise that's how we go about that one. And thank you very much for watching.